How strong is ABS reinforced with Kevlar fibers? I don't know. I'm testing this type for the first time. Hello, welcome to my tech farm. New filament type on the test today, ABS Kevlar by Spectrum. And as you can see, the spool is open with a reason. I bought this spool myself, but when I placed the order, I got an email that the waiting time will be between 11 and 12 weeks. They have some serious problems with the raw materials, and I wrote this in a comment somewhere, and one of my viewers from Germany saw this, and he offered me that he has some spool for the project. It was printed, and the rest he will send it to me for the testing. So huge thanks to him. He don't want his name to be mentioned. So this is not a sponsored video of any kind by the Spectrum, but this is still a sponsored video. Actually, the whole channel is sponsored by Polymaker, who is supporting my research activity. Let's talk about this filament. This is ABS filament reinforced with Aramid fibers or Kevlar. And the properties which they mention on their website are more compared to the regular no-fiber reinforced ABS, like reduced shrinkage, better dimensional accuracy. And this is actually a very important property for me because I like the properties of the regular ABS, but that dimensional accuracy is sometimes problematic. That shrinking sometimes cannot be compensated in a slicer. Reduced density 1.05 liters per kilogram, but this is somewhere exactly in the middle of the range for the regular ABS, so maybe this is really comparison with the carbon fiber version. High rigidity and impact strength, and stronger layer lamination. We will see, because the disadvantage of the carbon or glass fibers is that they improve the rigidity and stiffness of the printed object, but they will reduce the cross-section, and with this the layer adhesion. And here they claim that this will have a strong layer adhesion. Well, we will see soon. Let's see some recommended print settings. The nozzle temperature between 250 and 270 degrees Celsius, bed between 80 and 100, same like with the regular ABS material. Speed between 0 and 150 millimeters per second, and cooling between 0 and 50%. Now in the TDS technical data sheet, the information is a little bit different. The maximal speed is 70 millimeters per second, and maximal part cooling is 25%. Of course, the enclosure is recommended, and this is less abrasive like carbon or glass fibers, but we still need some hardened steel nozzle or similar. Let's see how brittle is this filament. Not too brittle, but let's measure it. Start angle 30 degrees. It's not even completely broken, so definitely this is not a brittle filament. Since I'm not familiar with the condition of the filament, just in case I will start with the drying, 6 hours on 65 degrees Celsius should be enough. Slicer settings, I started from Bambolab ABS GF, 60 chamber temperature, 90 on the bed, 270 the nozzle temperature, and 12 the maximal flow, and part cooling between 10 and 30%. My typical test objects. The start is good, and probably like other fiber reinforced ABS, it will be fine on this textured PI sheet without any glue. The printing is okay so far. I can feel that smell of the ABS. It is not so strong, but noticeable. And the last object will be printed soon. I wasn't here when it was finished. It was printed half hours ago. But even now the adhesion is quite good, but already removable. Let's check the shrinking. The design length is 80 mm. Now I will try to measure about the elephant foot. 79.63. This means the shrinking is not much smaller compared to the regular no-fiber reinforced ABS, which average will be 79.6 mm. From my pattern summary table, I am selecting the ABS filaments without any fibers, and these average values will be used for the comparison. I started my testing in a different order. This is 3-point bending test. Distance between supports is 50 mm, and I'm placing these loads and measuring the deformation after 1, 30 and 60 seconds. Currently you can see the constant deformation under 10 kilograms. And after this test, there is some minimal permanent deformation. The deformation is very similar until 5 kilograms. Now under 10 kilograms we can see some additional deformation on ABS Kevlar during that 1 minute compared to the average ABS, which is not really typical for fiber reinforced materials. Another bending test. This follows better the ISO 178 standard. Distance between supports is 64 mm and they're rounded 10 mm diameter. This is real-time speed because I want to show you the deformation, and it breaks quite suddenly but with a very big deformation. And you can see the maximal load is 106.1 newtons, and you can see the graph here. And here you can see the bending strength and elastic modulus. This is new test and I don't have enough data, so I have only here ABS GF, which is the closest. And here we can see that the ABS GF has much better bending strength and even elastic modulus. Impact test, I'm starting with the Sharpie, which is supported on two sides. And this is the result, measuring from 3. And this is the ISO, vertically holded test object. And results from 3 measurings. For the average ABS I have only ISO test results. The Sharpie I started much later. But anyway, the toughness is the typical property of no fiber reinforced ABS, and adding fibers will make it more brittle, and unfortunately that's what can be seen here. ABS Kevlar is noticeably more brittle compared to the average ABS, but still tougher compared to the average PTG, for example. Creep test, the deformation on a constant load of 1.25 kilograms. 2 on the left are PLA filaments, and the last one on the right side is this ABS. 16.23. Quite big deformation for the fiber reinforced material. Day 5 and typical behavior. Initial deformation was bigger on this ABS, but now after 5 days, even with the bare eyes, we can see more deformation on PLA materials. And this is typical for these filament types. 17.40. Removing the load. On this graph we can see the distance between two reference surfaces, and we can see less initial deformation on ABS Kevlar. But after day 1 they became almost equal, and from here their deformation is very similar, but the difference between 2 days is the creeping that's presented on the second graph, and here we can see that bigger creeping on day 1, but after this the creeping is very similar. But from fiber reinforced material I was expecting better properties. Tensile test with horizontal printed objects. This property was a little bit disappointing, noticeable weaker tensile strength compared to the average ABS. Layer adhesion, vertically printed parts. And this one was really a pleasant surprise, so this is a good layer adhesion. This is my rating for this test object, and noticeable better compared to the average ABS. Shear test, side by side horizontal and vertical objects. Printed in horizontal position, usually fibers helps a lot here, but these two values are very similar. Printed in vertical position, the layer adhesion is important, and yes, definitely ABS Kevlar is better compared to the average ABS. Torsion test, side by side horizontal and vertical. 1.3. Measuring the load in Newton meters. Similar numbers, but a different behavior of the test objects. In horizontal position, load in 90-degree rotation, the values are very similar. In vertical position, again layer adhesion is important, and here we can see some advantage on the side of the ABS Kevlar. Temperature test in the oven. This one is the filament from this video. I have several tests in the progress. The average ABS, 94.3 degrees Celsius. And this one was quite close. At approximately 92 degrees Celsius I noticed the first deformation. At 115 degrees Celsius I took it out, but very quickly it became hard and solid. Wrench test, and somehow I started to like this experiment. I even have 2 videos about testing different materials, and I'm measuring the brake torque in Newton meters. Box and wrench, and the battery died, but I could catch the latest moment before it turned off, 2.0 Newton meters. And results from earlier videos. You can pause the video if you want to analyze it. Or results one more time. Creep test. Tensile test and the layer adhesion, shear test, horizontal and vertical, bending test, the deformation after 30 seconds, bending test, deformation under these loads after 1, 30 and 60 seconds, torsion test, impact test, ISO and Sharpie, temperature test, and a new bending test. Somehow I'm not really sure about the purpose of this filament. Compared to the regular no-fiber reinforced ABS, it has very similar mechanical properties. Maybe the tensile strength is even weaker a little bit. On the other side, the layer adhesion is improved, but we still have very brittle material, which is typical for fiber reinforced ABS. I really appreciate the novelty. They try to do something new here, and I want to give one more chance to this type of the fibers, because I couldn't find this from the other brands, but I have here ASA reinforced with Kevlar, and it will have a direct comparison with the carbon and glass fiber ASA, also from the same manufacturer. And I hope we will get a clearer picture between these three fiber reinforced types. I hope you will follow me to that video too. Thank you for watching this one until the end, and happy printing!